Okay, thank you very much, everyone, for attending. I think it's just gone 2 minutes past the hour, so we're ready to kick off. Let me take you through the agenda of what you can expect on the session this morning. All right, thank you. So today's agenda looks like what you see on screen. So we've got a welcome and introduction. We've got an introduction to sustainable manufacturing, which we found to be very, very interesting. This webinar is backed by an ebook on screen, which you can get access to but later on. We go into the 6 considerations for sustainable machining. So from a manufacturing perspective, we always want to be, sustainable in how we do it, in our processes, as well as the tools that we use, and how best can we be sustainable. And this webinar tends to answer these questions that we may have. And following on, we've got a question and answer session, and then, of course, a close. So just a quick welcome. My name is Daniel. So for people online that know me, and for the ones that don't know me, I've been in the Autodesk industry for over a decade now, with experience in the manufacturing and process plant industries. I head up the manufacturing industry here at Baynes, and I have various experiences when it comes to data management, as well as the manufacturing tools. My qualifications include mechanical engineering as well as proficiencies in various Autodesk applications. However, you're not going to hear too much from me today. I'll get to my colleagues that I'm going to introduce to you shortly. So before we get there, I just want to take you through who we are. So for the people online that don't know who we are, Baynes is a niche consulting company that specializes in design solutions. So we don't just supply design tools, we help you adopt these tools from a process perspective, which looks like consulting, education, hardware, and software. From a consulting perspective, we focus our efforts on looking at the people, the process, as well as the business assessment side of it. So ensuring that adoption is effective and you're making the best use of the tools that you have. And we've got various consulting activities from a building perspective, data management, CAD/CAM, which is what we're going to talk to a bit more, as well as simulation. From an education perspective, we specialize in training. So we've got an authorized accredited training center. We also work with companies from a self-paced learning perspective, and we support the blended learning approach with e-learning tools like Clinical Series, as you see online. And from a hardware and software consulting perspective, we are Autodesk Gold partners. We specialize with Leica as well as Clear Edge for the extra bits that make up the design workflow. We've got quite a bit of expertise in various industries, from the building, civil, energy, process plant, as well as manufacturing. And today you're going to hear a bit more from our manufacturing specialists. So today's speakers, I am honored to welcome my 2 colleagues. Firstly, Peter Watson, who's been a stalwart in the manufacturing industry for over 7 years now. He's got specialist qualifications from a CAD/CAM perspective. He's spent time optimizing workshops, optimizing processes in the past, and some of you may know of his expertise. He is a certified Autodesk instructor, as well as he's got quite a bit of background and knowledge on the other aspects of the Autodesk offering, like the design tools as well as data management. And joining Peter today would be my colleague, Michael Smith. And Michael, he's got quite a bit of industry experience from a manufacturing perspective. He specializes in manufacturing. He's got quite a bit of passion when it comes to the design side of it, as well as CNC. He's got very acute knowledge around the 3-axis and 5-axis machining. He holds an honors degree from the University of Pretoria, but he's also very passionate about design and manufacturing. So without further ado, I'm going to hand you over to Michael and Peter to take you through the rest of the session.
Okay, hi, good morning, and welcome to the webinar. Thank you for joining. I'm Michael, and today we're going to be talking about why sustainable manufacturing is important. And then we're going to look at different strategies that can be implemented to improve the sustainability of your machining workshop, with a specific focus on CNC manufacturing. We'll talk about the tools that Autodesk Fusion has that can help you achieve these sustainability goals. We've got a Q&A section that you'll find in the webinar platform. So if you have any questions as we go along, you can pop them there in the Q&A section, and we will try at the end to answer as many questions as we can. All right, so yeah, we've all seen these graphs, and we've seen the evidence that the environment is changing, the climate is changing more rapidly than it has in the past. Yeah, we've seen carbon dioxide levels are rising. We've got scientific evidence that things are changing. This global sea level has been increasing due to the melting of the polar ice caps and in Greenland. So yeah, this makes it very evident that we need to start making changes to the way that we do things, especially in manufacturing, to try and flatten the curve, as it were, of these environmental changes that can and are starting to have dramatic consequences on our lives on the planet. Okay, so we've got a quick poll here that I will present in a second. My apologies. It's our first time on a new platform. Okay, so you should see that poll come up, and we will give you a few minutes to choose one of those options to let us know what the importance of sustainability is to you and your manufacturing workflow. Cool. Yeah, I see a lot of results are coming through, so I appreciate your feedback. Cool. Yeah, so I see that, yeah, for a lot of people it is important, but it's perhaps not the highest priority. And I know it is very difficult, especially in the economic situation that we're in, to prioritize sustainability, because it is it can incur more costs. But yeah, we're going to show you some tools where you can, as well as saving, as well as increasing the sustainability and efficiency of your manufacturing, you also bringing yourself cost saving tools. All right. So I'm going to hand over to Peter now. Yeah, who's going to bring us some statistics on what the impact is on machining.
Great. Thank you, Michael, and thank you, Daniel, for the intro, and welcome everybody to the webinar. Thank you for joining us once again. So the statistic that's now coming up on the screen over here, I think it highlights the significant impact that manufacturing, as well as the production sector, has on global carbon emissions, as well as your energy consumption. We look at those numbers: 54%, 1/5 of global carbon emissions, 54% of the world's energy usage. These are high numbers, especially when you're talking globally. I think it underscores the sector's substantial contribution to both environmental challenges as well as energy demand worldwide. If we can reduce our emissions and obviously improve energy efficiency in manufacturing, These are critical steps in addressing climate change as well as sustainability goals on a global scale.
Okay, so what are the benefits of sustainable practices? Obviously, the most important benefit of sustainable machining is reducing the environmental impact of the manufacturing workspace. By reducing the carbon footprint of the workshop, manufacturers can contribute to the global effort to reduce carbon emissions and help slow the rate of increase of CO2. And yeah, as I was saying, there is an economic benefit to implementing sustainable practices. Reduce wastage of material results in less money spent on materials. Recycling waste material can also reduce the amount spent on new materials. So, and if we look at lower power consumption, that means lower electricity bills, and more efficient tool paths result in lower tool wear and less money spent on new tooling. So in the manufacturing environment, every small resource and amount is multiplied by as your production runs increase. So a small incremental change here over 100 products that you're going to manufacture using the same methods will, that'll kind of snowball the small changes that you make. Right, and then implementing sustainable practices can improve the image of your brand as consumers are becoming more and more conscious about sustainability and about the need for going green. People are going to try and align their buying choices with the products that you are delivering. Meeting regulatory requirements. So governments have been implementing limitations on CO2 production. They've created incentives for companies to lower their carbon footprints. And just a few weeks ago, President Cyril Ramaphosa has signed a new climate bill into law, which sets out some national climate change response, including mitigation and adaptation actions, and which also constitutes South Africa's fair contribution to the global climate change response. The act has the aim of strengthening coordination between the national sector departments and provide policy settings and decision-making to enable South Africa to meet the commitments in nationally determined contributions under the Paris Agreement. So we are starting to align with international standards of sustainability levels. Okay, so these are the 6 topics that we're going to look at throughout the webinar. First one being waste reduction. So what are the causes of waste reduction? So we started looking at material wastage. This is where, material wastage can result in, can be caused by programming errors, machine collisions, and tool collisions. So if you have a part that you've programmed, you're running, and if there is a collision with the part, perhaps your tool holder collides with the part, your tool is then your part is then wasted and will have to be scrapped, either recycled or perhaps potentially reused in another part. But we want to try and mitigate the causes of waste, so that we end up just using less material. Making fewer mistakes in our programming. And so Peter is going to take us through some real life examples of what we can do to reduce waste in our machine programming.
Okay, so the example we've got running on the screen at the moment, you'll see when the screen turns red, this is now the CAM solution picking up and basically letting you know that there's a collision. Every time you see red, you'll see the machine, there was a collision with the holder as well as with the actual arm on the machine as well. So look, and this is basically a rapid movement into the stock. Sadly, these mistakes are quite common in workshops, especially for the guys who are still doing manual programming. It's also a very easy mistake to make. The problem with not having a solution like this is you have no foresight as to what's going to happen until you physically put the part in the machine and actually start machining it as well. Especially for the guys who are still manually punching your G code into your machine's control. Some of these programs, depending on what you're machining, they can be thousands of lines. All it takes is one decimal value to be in the wrong place for a typo error, and you can send your machine spindle sending in an opposite direction. By having a digital twin, this eliminates the risk to your machine, as well as giving your operations or your operators more confidence to learn. There's no real world confidence or consequences in the digital world. So you can push things a lot more. You don't always have to be so conservative. You can take more risk without the real world disaster of actually crashing a machine. Go to the next. Okay, so obviously when it comes to machine crashes as well, this is also sort of largely dependent on your operator's experience. In South Africa, experienced operators are very difficult to find these days. So, we need to now upskill the newer guys who are coming up into the ranks. Sadly, newer operators, they're often more prone to making mistakes during the learning process, which again is quite costly when the guys are doing it physically live on the machines. This is very expensive. Crashed CNC machines cost a lot of money, as well as time to repair as well. With CAM simulations, as we are playing up on the screens now, you can have a 3D model of your machine, your vices, your work holding devices, as well as jigs. So in other words, if you've got a fancy jig now to basically clamp onto the table, you can actually have that live within your simulation as well, thus creating a digital twin of your machine that you have on the floor as well. Mistakes are a part of learning, obviously. However, on a CNC machine, this is a very costly mistake. You can always undo an error on a computer, Control Z. This is not an option on a CNC machine, making operator development stagnant as the risk is too high. Okay, so now in this case now where we've had a collision, Mike, just go back one.
Okay, sorry.
There we go. Okay, so on the video now, how do we fix where that faceable cutter went and clipped the side of the job? Again, you can go and you can, having the ability to have that visual representation, what your machine will do, like I was saying, it gives you a lot of foresight. These simulations will check for collisions, as we saw earlier when it went red. They will also take into account your tool length, as well as rapid collisions with stock or your work holding devices. Visual representation of tooling, that now what it's going to show you is it's going to show you the type of tool being used, how many flutes it has, the geometry of the tool as well, such as your tool diameter, your shaft diameter, shoulder and fluke length, as well as corner radii as well. And you can see there now we've got a nice clean operation. Regarding where the tool length was too short, here I'm going and I'm editing the tool. So all these values can be modified to match the tooling available on your machine. You can see there we've got our overall length holder, and you can obviously adjust all these values to match exactly what you have physically on your machine. This comes in handy not only for collision checks, you can also, by taking bigger step downs for more efficient tool parts, something that Michael is going to be covering a bit later, especially on roughing. You want to be taking the biggest depth of cut that you possibly can. You can also import your cutting data, such as your spindle and your surface speeds, feed rates for your lead in and leads outs, as well as vertical feed rates, such as plunging, how far you want it to then plunge into the job. All these functions together will increase efficiency, reduce collisions, as well as save time. The knock-on effects of that is it has a great impact on the environment, as well as making your workshop more efficient.
Okay, next we're going to talk about energy efficiency. CNC machines use a lot of power. As we saw, that 54% that manufacturing uses up of global consumption is quite a significant amount. Yeah, so machines, they use a lot of electrical power. In fact, according to a statistic, 80% of the power usage of a CNC machine is actually due to auxiliary components, or can be up to 80%. such as coolant pumps and chip conveyors, etc. So one of the ways to reduce the power usage of your machine is to try and minimize the non-running time of your machine, so that not just minimizing the time that it's cutting, is minimizing the time that it's running, that it's standing idle, essentially. Yeah, this is further to creating more efficient tool paths. So that's really important. I mean, that helps you in so many ways. If you can reduce the time that it takes to cut a part, it's going to reduce the amount of energy used. It's increasing the efficiency of the machine in terms of producing more in less time. Yeah, and again, having accurate simulation is going to help you create more efficient tool paths. And then further to increasing the non-running time of your CNC machine, an important factor is to look at is the post processor that you're using to generate the code when you're working with. So we want to move from manual programming to programming with your CAM system. You want to get the correct code output so that when you've sent a program to your machine operator, that he's not having to make edits, like add in a program stop, or to change a tool number, or to correct the coolant code or something that's incorrect that came from your CAM software. You want to optimize that flow of information so that it's a matter of copying the code onto your machine and hitting run and not having to worry about making any changes. And that comes from post-processor editing. So that's something that can be done with Fusion. You can fine-tune your post-processor to get your code out exactly as you need it. All right, so here's an example of an inefficient tool path. So here we've created a cylindrical stock, but you see there's a lot of material to be removed, and that results in a very long and complex tool path that may result in a lot of air cutting depending on our stock. So if we look at, perhaps we've got a cast stock, Fusion allows us to bring in that as a secondary model. So we have an accurate model of what the part looks like before it's been machined. And then you can see on the right, that image shows how much the tool path has been reduced. So that's just a roughing strategy. So that's removed that rough material, and we can tell Fusion exactly how much we need to remove. So you can see there's a lot less air cutting in that operation. All right, next we're going to look at cooling strategies, and I'll hand back over to Peter for that.
Yes, thank you, Michael. And also just to, especially on air cutting, for the guys who maybe aren't fully into the machining side of things as well, where your tool is not engaging material, just by reducing air cutting, it benefits everybody, not just the environment. So onto cooling strategies. Your CNC machines, they require coolant for several important reasons. First one is heat dissipation. During your machining operations, the cutting tool and your workpiece will generate sufficient heat due to friction of material removal. In other words, where your tool is not cutting into the material. Coolant will help dissipate this heat, preventing overheating of the tool, your workpiece, as well as your cutting zone. Overheating can lead to dimensional inaccuracies, premature tool wear, and even damage to your actual machine. The second one is tool longevity. So coolant will help extend the life of your cutting tools by reducing friction and heat. Prolonged exposure to heat without adequate cooling can cause tool edges to wear down quickly or even soften. And again, as we know, friction causes heat, which will cause your tool and your workpiece to expand. As they get colder, it's going to contract, and you want to obviously try and keep that to a minimum. The third one is chip removal. So coolant will help flush away your chips or your metal shavings and debris, which is generated during machining. Efficient chip removal also helps to prevent your chips from accumulating in the cutting zone, which can actually cause tool breakage. Your poor surface finishes, where the tool is now scraping on shavings, it does mess up your surface finish, or interfere with subsequent machining operations because it's just in the way. So coolant will keep the temperature down, but it also sprays it off your workpiece. The fourth one would be reduced workpiece distortion. So intense heat generated during machining can cause thermal expansion, as you were saying, hot things expand, and distortion of your workpiece material. Coolant helps maintain more consistent temperatures, reducing the likelihood of workpiece distortion, as well as improving your overall machining accuracy. Okay, so the choice of coolant can have negative or positive effects. It plays a critical role in determining the sustainability of a machine's operation. Whether it has positive or negative impact hinges on several factors that influence efficiency, longevity, as well as the environmental impact. By carefully considering the properties and implications of different coolant options, manufacturers can significantly influence the overall sustainability of their operations. This choice not only affects performance, but it also contributes to the broader environmental and economic goals. Thus, understanding the ramifications of coolant selection, as well as the disposal, is essential for achieving sustainable machining operation. Okay, so what is coolant? What is it? What is it made of? And it's obviously a highly chemical substance as well. So if you look at the chemical composition, it contains many chemicals such as harmful oils like biocides. There are corrosion inhibitors, formaldehyde, which is a particularly nasty one. Sadly, this is also prevalent in most of the coolant suppliers in South Africa as well. This not only causes massive damage to the environment, but as well as your operator or your machine operator's skin tissue. If you look at these guys who've had their hands in coolant all day, it's really not good for your skin as well. These chemicals are not only toxic to your operator, as well as to aquatic life, if they enter into the waterways through improper disposal or leaks. I mean, we've actually seen situations where coolant is being dumped down the drain. It's shocking. Contamination. Coolants can become contaminated with metals, particulates, as well as microorganisms during machining operations. Even a human body, if you realize how much is actually living on us, when you got your hands in that coolant, that is all now being passed into it as well. Contaminated coolants require special handling as well as disposal procedures to prevent environmental contamination. Often these are not followed, and I've seen this being poured down the drain, as I mentioned earlier. For the guys who do have CNC machines as well, if you go and look at your coolant tank after a year and you can see what's living inside there, it's quite eye-opening sometimes. Waste generation would be the third one. These coolants are often used in large quantities during CNC machining. So if we take a pretty straightforward 3-axis VMC milling machine, those will take about 100 liters. Your bigger machines going up to sort of 200 liters. Disposal of spent coolant can contribute to waste generation, especially if not managed or recycled.
All right, so now we're going to take a quick poll, and so we want to get your feedback on what type of coolant are you using if you're running a machine workshop, and otherwise, which cooling strategy have you heard of? Which ones are you familiar with? Cool, yeah, I can see your results coming in. Okay, thanks. Yeah, so you can see from those results. Yeah, the results of the poll. Yeah, we can see that most common is flood. That is the most commonly used coolant strategy. And we see we have some results there on the minimum quantity lubrication. And we'll talk about that in a second. All right, so Peter has explained to us why coolant is important and what the constituents of the coolant is. So yeah, we spoke about flood cooling. The flood cooling, yeah, it's the most commonly used one. It is one of the least environmentally efficient one. We've seen, yeah, it contains a lot of potentially harmful substances. It requires a lot of material, a lot of cooling liquid, because you're essentially flooding your whole part. You're covering it with as much coolant as possible to try and to remove as much heat to keep your tool cool. So by way of comparison, dry cutting, which is not commonly used because of the drawbacks, of course, it would have a sustainability impact because you're not using any coolant at all. So there's no contaminants, there's no product that needs to be disposed of when it becomes unusable. But of course, in dry cutting, you're looking at getting a lot of heat buildup, and yeah, which has all those drawbacks. It's going to dull your tool faster, can have an impact on the accuracy of your part. So that's not really a suitable way to go with most materials, especially metal. If you're looking at cutting timber, then you're usually fine with dry cutting. There's no coolant needed. You can just use compressed air to remove chips in that situation, which is really the only way of reducing tool wear and heat buildup. Okay, so then we can look at a more advanced cooling strategy, which is minimum quantity lubrication, or MQL. So what that does is, instead of flooding the whole part with a whole lot of liquid, we're now directing a stream of coolant material, which is usually a small amount of oil mixed with some additives. And this is directed with compressed air to direct it at the cutting point of the tool, because that's where most of the heat buildup is happening. It's where the chips are being ejected from the part. So now we're just directing the coolant right at that cutting edge. So it's a lot more effective using far less material. So of course, yeah, this has a environmental benefit that we're not having a lot of material that we have to dispose of. All right, and then there's cryogenic. So this, again, is very advanced, a new approach to cooling. This is where we're using liquid nitrogen to supercool the part and the tool to keep the whole thing at a low temperature. So there's almost no heat buildup. Yeah, so it really works efficiently and effectively. And then, of course, there's no material to be disposed of again, because it's nitrogen. It dissipates into the atmosphere, and it's not causing any harm. So the downsides of cryogenic is that it can only be used on very hard materials. Otherwise, you might incur breakages. But yeah, it's appropriate to use on medical alloys and aerospace alloys and hard polymers such as PEK and silicon. So yeah, this can improve your cycle times. You can cut a lot faster. Cycle times between 40 and 400% faster, and it can actually improve the quality of your finish. That's something we didn't touch on, is that using the right cooling can give you a better final finish to your product. Okay, and I'm going to hand over to Peter, who is going to talk about green tooling.
Okay, so yeah, green tooling. You know, there are many guys, many tool suppliers available out there. And I mean, those guys are playing the game as well, you know. Tools are made to a much higher standard these days. So, you know, machine tooling is commonly made of cemented carbide. So if we look at your high hardness and wear resistance, cemented carbide tools are extremely hard, as well as being resistant to wear. It makes them ideal for machining tough materials like steel, stainless steel, as well as your high temperature alloys. Extended tool life. So due to their hardness as well as their wear resistance, cemented carbide tools have a much longer lifespan compared to tools made from conventional materials like steel, as well as your high-speed steel. This reduces tool replacement frequency as well as downtime. Again, the less often you have to replace your tools, the longer they last, the better it is going to be for the environment. They don't have to make as many. Improved machining accuracy. So carbide tools maintain their dimensional stability as well as your cutting edge integrity, even under high cutting temperatures as well as speeds. This now leads to improved machining precision as well as giving you a better surface finish. Versatility. Cemented carbide tools can be used across a wide range of machining operations. This includes turning, includes milling, drilling, as well as cutting. The reason for this is the ability to withstand various cutting conditions as well as materials. Resistance to thermal deformation. So carbide tools also have high thermal conductivity as well as resistance to thermal deformation. This will help maintaining dimensional accuracy as well as avoiding tool failure during high-speed machining when you're pushing the tool a little bit. Reduced machining costs. So despite the initial cost, because obviously now you think the more advanced tools, guys still buy cheap tooling because it's cheap. So yes, you will pay more for more expensive tools, but they will last a lot longer. So despite the higher cost, cemented carbide tools can reduce overall machining costs by improving productivity. You can use much faster cutting speeds. You're going to get much longer tool life, as well as reduce scrap rates. Sustainability for high-speed machining. Again, going back to the carbide tools, these are well suited for high-speed machining applications where your cutting speeds, as well as your feed rates, are increased thanks to their heat resistance, as well as their hardness. They're obviously built to be a lot harder. Environmental benefits of this. So cemented carbide is very recyclable. Your recycling programs for carbide scrap help in reducing environmental impact associated with mining and processing raw materials like your tungsten cobalt. Very, very common there. Okay, so now by ordering less tools, just go back one, Mike.
Sorry.
No worries. So environmental benefits. This now reduces the need for extracting raw materials from the earth, which helps in preserving natural resources and habitats. And again, the guys are now having to come to make less tools. When you're looking at energy conservation, you can recycle these tools. Recycling typically requires less energy compared to actually extracting and processing the raw materials required to make new tooling. This now will lead to lower carbon dioxide emissions, contributing to climate change mitigation. Ethical sourcing, big one. So recycling decreases the demand for new materials, including those like cobalt. Anyone who's seen how cobalt is mined will know what we're on about, which often come from mines with questionable ethical as well as environmental practices. This promotes more responsible sourcing practices, as well as supporting sustainable development goals. If you look at resource efficiency, recycling also extends the life cycle of materials, promoting a circular economy where materials are reused and repurposed rather than just discarded, thereby maximizing resource efficiency. Promotion of innovation. So recycling also encourages innovation in technology as well as processes aimed at improving efficiency and reducing environmental impact on material recovery and reuse. The next thing that it's also going to benefit is job creation. So yeah, the recycling industry creates a lot of jobs, especially in collecting. You need to source it, processing, as well as manufacturing of recycled materials. This also contributes to economic growth as well as sustainability. Up on the screen here, we've got a variety. So yeah, this is just a selection of the kind of tools that are used in manufacturing, especially on mills and lathes. So recyclable cutting tools, in other words, cutting tools made from recyclable materials like carbide insights or coated tools that extend lifespan are designed by most of the tooling suppliers for easy recycling after use. So if you have a preferred tooling partner, or if you are looking at the different tooling options that are available, always good to check these kind of things, especially for moving forwards. Some of them also have non-toxic coatings as well as and finishings. These tool and dies coated with non-toxic or low VOC finishes that provide corrosion resistance as well as durability while minimizing environmental and health impacts. When I'm saying low VOC, this refers to volatile organic compounds that are not harmful to the environment as well as to humans.
All right, now we're going to have a look at sustainable materials. So, what are the characteristics of sustainable materials? We want to look at products that are recyclable, so that once they're manufactured, once they've reached the end of their life, they can be recycled and then repurposed into other products. We want to look at material that has already been recycled. So instead of always getting virgin material that's mined and has a high embodied energy, we want to use something that's coming from a recycled source. And we also, it's something that's more of a design consideration, but products that are reusable. So if you want to create something that, we're looking at not creating one-off parts that are used and then discarded. We want to create products that are reusable and have longevity.
Okay, so now, in terms of material, what are good examples of sustainable materials to be used? First one is aluminium, luckily very common as well. It's lightweight, it's recyclable, and it's widely available. It requires much less energy to produce compared to other metals like steel. It can be easily recycled without losing its properties as well. This makes it a great choice for various CNC machining operations as well as being sustainable. The second one is brass. It's an alloy of copper and zinc that offers good machinability as well as corrosion resistance. It's also recyclable, which contributes to reducing environmental impact. Brass is commonly used in CNC machining for parts that require good conductivity or aesthetic appeal. In other words, it looks nice. Engineered woods for the routing guys. Sustainable woods such as bamboo, reclaimed wood, or FFC. SA certified wood. So FSC, that stands for Forest Stewardship Council of South Africa. Very good to go and Google those guys. Are used in CNC machining applications like furniture, signage, decorative elements. These woods come from responsibly managed forests or are made from rapidly renewable resources. Another one is bioplastics derived from renewable resources such as starch, sugarcane, and cellulose. They're becoming more popular in CNC machining. These materials offer biodegradability or recyclability advantages over traditional petroleum-based plastics, great for sustainable rapid prototyping. And machining plastic is no easy feat. The other one is titanium. So it's lightweight, it's also very strong, as well as being highly durable, and as well as being corrosion resistant. While it requires more energy to produce than aluminium, its long lifespan, as well as ability to be recycled, make it a good sustainable choice for CNC machining in industries like aerospace, as well as medical. Another one is cast iron. So cast iron has great machinability and durability. It makes it suitable for heavy-duty applications in CNC machining. It's also very recyclable, which helps reduce environmental impact. The last one I noted here is ceramics. So advanced ceramics such as alumina, that's aluminum oxide, as well as zirconia, are used in CNC machining for applications requiring high temperatures and resistance, wear resistance, or electrical insulation. These materials are durable and can be recycled or reused as well.
All right, so thanks, Peter. So fortunately, most common metals can be readily recycled, with steel being actually the most recycled metal in the world. And most steel and aluminium products are already contain between 25 to 100% of recycled material because of the recyclability of these materials. They can be indefinitely recycled. There's very little material that is lost to corrosion, especially in the case of aluminium, where it doesn't corrode. Where steel, if it's not recycled, it will rust and corrode and sort of return back to the earth as it will. Okay, yeah, it is. It's worth considering where the energy used to produce raw materials is coming from. Is it coming from a sustainable source, such as solar or wind farms, or is it coming from fossil fuels like coal and oil? So more and more manufacturers in South Africa are returning to renewable sources of energy, largely due to the impact of load shedding, but it is also in a move to reduce their carbon footprint. All right, so high-speed machining. We're going to look at some new approaches to machining strategies. There are different ways we can approach creating tool paths in order to improve the sustainability and efficiency of our machining processes. So here you'll see in this diagram, what is high-speed machining? So high-speed or high-efficiency milling is where, yeah, conventionally we'd take a shallow cut just using the tip of the tool to reduce the force on the tool. We want to take a shallow cut, and then we're going to take multiple passes, multiple step downs to ensure that we don't have tool breakages, that we're not putting too much force on the tool. We want to stay safe. We're going to have multiple passes, but we can rather look at, instead of taking a shallow, deeper cut, so a wider cut, we're going to take a thin cut, but we're going to cut with the full length of the tool. And we can see how, you'll see the color there, we've indicated it in orange. It's not heating up as much. The heat buildup is distributed along the full flute of the tool. So you're reducing the amount of tool wear. You're reducing the amount of deflection in your tool, so you're getting a more accurate cut, but you're also ending up with a much faster cut. You can move faster and you can take fewer passes to achieve the same result. Like in this demonstration here, I'm going to show you. So this is where we're taking shallow cuts. It's taking much longer, and we're using only the tip of the tool, so you're getting up all your heat buildup is ending on the end of your tool, which is going to blunt in much faster than the rest. You're going to end up with a tool that is not perfectly straight anymore, in fact, because you're having more wear on the bottom, on the tip of your tool. So Fusion has a strategy called adaptive clearing, and this is designed to make use of high-speed machining. So you can see here that operation, which took around 2 minutes, is now taking less than a minute to achieve the same results with improved tool wear and much faster machining time. Okay, now Peter is going to discuss a few more strategies in Fusion for high-speed machining.
Yeah, thank you, Mike. So, you've touched on adaptive clearing as well. So, using these kind of strategies definitely contributes to environmentally friendly machining practices. It minimizes waste, also conserves energy, it's going to extend your tool life, and it's going to reduce your carbon emissions. These benefits align with global efforts to achieve sustainable development and minimize the environmental impact of industrial activities. So the nice thing, go to the next one, is on adaptive clearing. This is a 3D toolpath, and the big advantage of something like adaptive clearing is it requires no input from the user. These toolpaths have been developed with this in mind already. So if you look at adaptive clearing, it will give you less material waste. So adaptive clearing, basically what it does is it optimizes your toolpaths to minimize material removal. This reduces the amount of waste material generated during machining operations. This efficiency can help conserve raw materials, as well as reduce the environmental impact footprints associated with material extraction and disposal. Like I mentioned earlier, it's basically automated, so it requires no input from the user. You'll also get lower energy consumption. So by optimizing your tool parts, as well as reducing the amount of material that needs to be machined away, adaptive clearing can lower overall energy consumption during machining. This is particularly significant in industries where energy-intensive machining processes are common, especially for high production, where machines never stop, these sort of 24-hour-a-day shops. Saving 1 minute per operation for a machine shop that's running 24 hours a day will add up to a significant amount. Extended tool life. Again, as Michael showed there, you're doing much bigger depth of cuts and you're utilizing the full flute length of your cutter. This is going to extend your tool life. So these strategies are designed to maintain consistent cutting forces and reduce your tool wear. Less air cutting. It will remember your stock removed from previous operations as well. This extends to the lifespan of your cutting tools, reducing the frequency of tool replacements. And as we said earlier, fewer tool replacements means less energy and resources used in manufacturing new tools that need to constantly be replaced. Reduce CO2 emissions, so with less material waste, with lower energy consumption. Adaptive clearing definitely contributes to reduced carbon dioxide emissions associated with machining operations. Improved efficiency in the workshop. So these algorithms optimize machining processes by dynamically adjusting cutting speeds as well as your feeds based on real-time conditions, and supporting sustainable practices. So this promotes the sustainable manufacturing practices by prioritizing resource efficiency as well as waste reduction. This can enhance overall sustainability profile of any manufacturing operation, appealing to environmentally conscious consumers as well as stakeholders.
All right, so yeah, our key takeaways. We've spoken about the importance of sustainability, why we should be trying to alter our machining practices to improve the sustainability of our workshop. And we've spoken about a few ways that Fusion can help you achieve these goals. There's built-in strategies that are geared towards creating more efficient strategies, the adaptive toolpaths, and Fusion has it has a great post-processor engine where we can make sure that our machine is outputting the correct code. And we also have, within that post-processor editing, we can allow us to use more advanced cooling strategies rather than the conventional ones, which are less sustainable. And it's easier than you think to implement these changes. It's not that you have to refit your whole workshop. You don't have to buy more machinery or spend a lot of money to make these changes. They're simple things that you could do in your programming, in your material choices that can have a significant impact on your carbon footprint. Okay, now we've got a bit of time for some Q&A. If there's anyone who has any questions, you can bring them up now. I'll have a look if there's anything here. Okay, yeah, so if anyone has any questions on these topics, you're welcome to pop that into the Q&A box. All right, so I see no questions coming up. That's all right. So we've also created a Future of a Sustainable Machining ebook. It just includes a lot of content that we shared in this presentation, but it's in a nice PDF format, and you can refer back to some of the strategies and ideas that we've presented. You can scan this QR code to get access to that book. And I'm also going to just make sure the link has been shared in the chat. Yeah, so that's there in the chat, so you can go and download that free ebook for your reference. All right, yeah, so we've spoken about that there is a serious need to implement more sustainable machining practices, and You're welcome to reach out to us at Baker Baynes. We can provide you support and training to help you implement some of these strategies. Yeah, and that's it for today. Thank you so much for attending. We hope we've given you some great ideas that you can then maybe look at implementing in your workshop to improve the situation that we've found ourselves in as human beings. And we want to try and preserve this planet because it is the only one we've got, and it is actually pretty amazing. Yeah, once again, thanks again for attending, and hope you guys have an excellent rest of your day.